we were discussing about the organic chemistry or the naming of the organic molecules. And in the previous lecture, we have already discussed the family name of the organic compounds, alkane and alkene. And today we will finish our topic on the alkyne and the alcohol. So briefly, what we have already discussed, all these three are also called the hydrocarbons because all molecules relating to the alkane, alkene, and the alkynes are only having the carbon and the hydrogens as shown over here. That's why these are called the hydrocarbons. And the difference between all these three hydrocarbons, you can easily identify which one is the alkane, which one is the alkene, and which one is the alkyne based on the number of bonds between the carbon and carbon. So if there are single bonds between the carbon and the carbon, these are called the alkane. If there is the double bond, it is called the alkene. And if it is the triple bond, it is called the alkyne. And we have already discussed in the previous lecture, you can name with the ane, ene, and ine, and the rest will remain the same. Eth, and that means this is relating to the two number of the carbon atoms, and if there are two number of carbon atoms and it is alkane, then the name is the ethane, and ethane is related to the alkane, ane, that is coming from the alkane. And similarly, these are also two carbon atoms, and the eth will remain the same, but it is ene because there is a double bond. And in a similar way, that is called the ethyne because it is there is the triple bond, that's why it is the ine, but eth will remain the same because there are the two carbon atoms. And similarly, we will move to the third one. So just refreshing your knowledge, so with the alkanes, you can easily identify and you can write the molecular formula of any of the alkenes starting from the carbon number 1 to carbon number 10. Let's suppose what we have already named these are the methane, ethane, propane, butane, pentane, and this meth belongs to carbon number 1, eth2, prop, that is 3, but 4, and pent 5, and similarly it goes so on. So this is the general formula. N is the any number of the carbon atoms. So how can you write the molecular formula of the alkanes? You just put the number over here. Let's suppose I am putting the 5 over here. That means there are 5 carbon atoms, and this is written over here. This is the number of carbon atom, its structure, and its name. And actually, you can write the number of the hydrogen atoms by looking at the number of the carbon atoms over here. So if there are 5 number of carbon atoms, then n would be the 5. Then 5 multiplied by 2 is the 10, and plus 2, that would be the total answer would be the 12. So you can write the molecular formula by using the simple general formula for the alkane. This is particularly for the alkane. And so you can even count the number of the carbon and the hydrogen over here, 1, 2, 3, 4, 5, because these are the 5 number of carbons. Now the number of the hydrogens, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as we have already calculated by using this formula. And similarly, you can go for any of the number of the carbon atoms, and you can write down the molecular formula of any alkanes if you know the number of the carbon atoms. And similarly, let's suppose if there is I'm using the simple one, if there are the 3 carbon atoms, then n is 3, then 3 multiplied by 2 is the 6, and plus 2, the total answer would be 8. And here 3 plus 3 and 2, 8, it equally justify the molecular formula if you use this general form of the alkenes. And similarly, this we have also finished in our previous lecture, and this you can also use this formula to write down the molecular formula of the alkenes, and this is just is similar to this one, but only it is not having the plus 2 over here, and the simple formula is the CnH2n. N is again the number of carbon atoms, and you just multiply the number of the carbon atoms by 2, you will get the answer for the hydrogen atoms. Let's suppose these are the, if the number of the carbon atoms are 7, so this is 7, so multiply 7 multiply 2, that is the 14, and this is the structural formula or the molecular formula of the carbon number 7, and here you call it the, this is the hept for the 7, and ene because there is the carbon carbon double bonds. So this nomenclature will remain the same starting from the H and ending with the dec, and just you are adding ene because of these molecules are having carbon carbon double bond. Now I am moving to the third one, alkyne, and I will use the whiteboard to draw one of the structure formula of the alkynes later on. But here you again understand the nomenclature will remain the same, starting with the H, and you may note that there is no one carbon atom is here because there is no possibility of the carbon to form the triple bond with the hydrogen. So that's why it is starting with the carbon 2. There is only possibility to form the carbon-carbon triple bond if this molecule is having at least 2 carbon atoms. That's why we are starting with the 2 carbon atom. And with the 2 carbon atom, it is called the eth. And we are ending with the ine because this is the alkyne having the carbon-carbon triple bond. And similarly you may go further with the with the 3 carbon atoms, and it is called the prop and ine because of having the carbon carbon triple bond, and it will go butyne and pentyne, hexyne. This one is indicating that carbon, this triple bond is at carbon number 1. So at your level, you may write without this one. You can just write down the butyne, pentyne, or the hexyne. And I have just clarified over here. This one is relating to the position of the triple bond, and it is at position number 1. And let's suppose if it is here, then it would be the 2. So you may write down the 2, but this is beyond your content of the course. So this is a simple way to remember what are the alkynes. So I will just finish this functional group, then I will move to the functional presentation of the alkyne and the alcohol. And this is another uh, molecule, and the family name is called the alcohol. This is the functional group structure. That means this is having the OH group, similar to the carbon-carbon and the carbon hydrogen. And if any molecule is having the OH group in its structure, these are called the alcohols. And here these line are actually the bond with the hydrogen. So there are 3 hydrogen. So this is a carbon 1, this is CH3, CH3 is there, and this is the OH. You can write in a molecular formula. And again, this will remain the same. Again, the counting will remain the same, as we have decided the 1 is for the meth, and you are just replacing the in with the ol, because here just remember over here these were the methane, ethane, propane, butane, pentane, and here what we are going to do with the alcohols, we are just replacing the e and adding the ol. So this will become methanol, ethanol, propanol, butanol, pentanol, and so on. So again, the counting will remain the same, and we are just replacing the last name of the molecules with the ol, and this is all about this molecule. Let's suppose this is an alcohol, and it is having the one, two carbon atoms, and for the two carbon atoms, it is called the eth. And if there is no OH, that would call the ethane, and we are just replacing the E with the ol, it will become ethanol. And similarly, with the three carbon atom, it will be pronounced as the propanol. Again, one is indicating that this OH group is attached with the carbon number 1, and that's why this is called the 1-propanol. And you may write down without the 1, 2, or 3 positions, because this is not covered in your content. So you just simply spell or write down the name of the particular alcohols by using the structure or the molecular formula. Again, if it is the, let's suppose if the actually one hydrogen it is replaced with the OH. That's why it will become the alcohol. So if I will attach the OH molecule, OH functional group over here, so I will be just releasing or replacing one hydrogen with the OH. So this only the last will become CH2 and OH, and the name of this alcohol would be the hexanol. So if you remember the nomenclature of the alkane, you can easily write down the names for the alcohols. So now I'm going to just draw one of these structure for the alcohol and the alkyne. So how it becomes the carbon-carbon triple bond. So let's suppose starting with the uh, ethyne. This is the, and ethyne mean there are carbon, number of carbon atoms are 2, and again valence electron for each of the carbon atoms are 4, and there are the 4 carbon atoms. That's why sorry, the total number of the valence electron would be 8. So you have to balance to draw the structure by using the 8 number of the valence electron. So let's start with the first skeleton. You must draw a carbon-carbon bond over here, and then now you can put the first is the this one bond, and the rest of the lone pair over each of the carbons. So there are the 3 and 3, 6, 7 and 8. You have rightly placed the 8 number of the valence electron over here. And if I just make a bond between carbon-carbon and the hydrogens, let's suppose again this would be the hydrogen, and this would be the hydrogen, and again with, if I attach the hydrogen with these uh, lone pairs, it will become the ethane, because there is only the single bond. And if again, as I explained with the ethene, one lone pair share to each other to form another bond, then it will become ethene. And now we are discussing how it will be the possibility to form the ethyne. So there is the this lone pair and this lone pair, because the covalent bonds are formed by the sharing of the electrons. So sharing of one electron from each side. So this carbon is having one electron, this carbon is having one electron, and when they share, let's see, I'm going to uh, place over here. So when they shared the electron, these were the first one with the single bond, and if these electrons are shared together, they will form another bond, and this will become the ethene. Now there is the possibility for the sharing of these two electrons, and when they share, and now there is the again possibility to form another bond between the carbon carbon bond. So the rest one would remain the same. This is the hydrogen. Sorry, I have not mentioned the, this is the one electron from the hydrogen, one electron for the hydrogen, because hydrogen is having one electron, so it will form the uh, single bond over here, carbon hydrogen. And similarly, this is the carbon hydrogen, and there are the one bond is there, second and third bonds. So the rest of the molecules looks like this, and this is the structure formula, structure of the ethyne, because it is having carbon carbon triple bond. So single bond is the ethane, double bond would be the ethene, and triple bond would be the ethyne. And in each case you must remember, this is going to fulfill the octet rule. And in each of the case it is not beyond the octet rule. If you look at this carbon, and this is having the if I place the hydrogen over here and also over here, this is a sharing of electron in case of the ethane. So don't mix up all uh, the bonding between the ethene and the ethyne. So this is the, let's suppose, so if you look at this a carbon, this carbon is having 2, 4, 5, 6, 7, 8. So valence, the octet of this carbon is also complete. And of course, when if there is one hydrogen atom is there, then the octet of this hydrogen carbon is also complete. And if you look at this carbon, in case of the triple and the double bond, the octet rule is going to follow. And here you can also count the total number of the electrons with this carbon. These are the 6 and these are the 2. And of course, the total number of valence electron would be the 8. And in this case, the total number of the valence electron, the total number of the electron obeying the octet rules are also 8. So 6 are there and 2 are there. These are the 8 number of the electrons. So in each case, the all molecules, either they are the alkane or alkene or alkyne, they follow the octet rule. So if you remember this rule, you can easily actually plot or draw the structure or the Lewis structure or the Dawes structure of any of the molecules. So just ending with the last one example, and this is the alcohol, and I'm taking the example of the, let's suppose this is the, if I start with the first one, and remember this is the only the carbon, 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 and the carbon, there are the carbon is having bond with the hydrogen. There are 4 hydrogens at given in the this structure, this molecular formula. This is a structure formula. So this is 1 carbon and the 4 hydrogen. And with the 1 carbon, the name is the meth, but it is the only the alkane. That's why this is called the methane, as we have already uh, discussed in our previous lecture. So now I am going to show you how the you can go for the alcohols. So for the alcohols, this 1 hydrogen is replaced with the OH. So I am just replacing the hydrogen with the OH. So what would be the next the final structure formula would be the hydrogen. This is the OH, and this is the H, this is the H, and this is also the H. Same. So just replacing the H with the OH, and due to this functional group, we call them the alcohol. And here the name of the alcohol is here. This is the meth, and you are just replacing the, similar to as you have replaced the H with the OH, you have to replace the E and put the OL because these are the alcohol. So the name of this molecule would be the methanol. Meth is from the carbon 1 and it would be the methanol. And similarly, if you add one more carbon over here, you can add any of the carbon 3, 4, and you would add the OH at any of the position. Remember, there should not be more than 4 bonds with the one carbon atoms because each carbon atom is having the tendency to form the 4 bonds. So rest will be all these line actually we show it is understood these are the hydrogens. So if this is 1, 2, 3, 4, and the 4 is for the but, and if it is hydrogen is here, then it is called the butane, and you can just replace the E with the ol, it will become the butanol, and the name of this alcohol is the butanol. So this is all about our today lecture.